My name is Colin Driscoll, and I am a flight dynamic systems engineer for the Landsat Mission Operations Center. I'm also a developer for the Meridian ground system, so I kind of have a unique skill set here where I both wrote some code for Meridian, and then I'm also going to be operating it for when Landsat 9 launches this September. So I'm hoping to be able to give you guys a unique look into Meridian. So you may have heard about Meridian, you may have heard about FreeFlyer. So I want to be able to show you guys how Meridian is going to utilize FreeFlyer to fly satellites. So let me go ahead and start the presentation. So what is Meridian? Meridian is a reusable software that meets 80% of a standard satellite's operational needs. So, it's going to cut down on any development time that a mission might need to develop a flight dynamics ground system. It's going to have your basic flight dynamics needs, your orbit determination, orbit propagation, maneuver planning for common orbit types, things of that nature. So that you can cut down on development time for such software. So yeah, it's going to be flying, like I said, Landsat 8 and 9. This September, it's going to be flying STP-SAT-6, Dream Chaser, and some JAXA spacecraft as well. So I wanted to give a basic overview of what Meridian, the software, actually looks like. So we have you access Meridian, the UI through either a web browser. You can access the API or the database through a terminal, or external code if you want to write Python scripts or whatever to access data or even run tasks. So you can access it through a variety of external software. And then the core of Meridian is this brown box here. We have a database layer, the user interface, our core API, an automation component, and then there's a separate component right outside the brown box there, which is our task processor, which serializes data from Meridian, sends it to the high-powered astrodynamics tool FreeFlyer to do all the propagations and any other astrodynamics calculations we need to do. And then that sends data back into our task processor component, and which gets reserialized back into Meridian and stored in either the database or wherever it needs to go within our software. So you'll learn more about the Meridian architecture in another presentation, so I won't go more into it. So what are you going to see in this demonstration? I'm going to show you how to configure things on both through regions and ground stations, etc., on the spacecraft. And these things are basically directly on FreeFlyer objects. So we have them in a nice, easy way to set in a UI, and it's just going to go right to FreeFlyer and configure the spacecraft to do whatever we need to do. And then we have when I reference Meridian products, I'm basically referring to any of these things, which can either be data to QA to look at, or data to export into file format, or to relay information to other ground systems, or even go in as an input to other tasks in Meridian. So I just wanted to speak briefly about what to expect to see here. So I'm going to go to the next slide, and what I'm going to cover is a simplified day in the life of what we're going to do when Landsat 9 launches, and we're generating products, nominal daily products, and what Meridian is designed to do. So we have these red boxes here, which are the tasks that I'm going to do. We have orbit determination, orbit maneuver planning, orbit propagation, and orbit product generation. And this is all spawned by the receipt of a GPS telemetry file, which is going to contain GPS data for 24 hours worth of data. And these green boxes are the Meridian products, which can be, like I said before, either inputs or outputs to these tasks. So I won't speak too much more on it because I'm going to be showing you right now. So let me show you what the Meridian UI looks like. So I'll take us right to the login page here. So first thing you see when you access Meridian through your web browser, I'm using Firefox, is we have a simple login page. You type in your username, passwords. Everybody knows what to do there. So okay, so this is our home page. We have it's going to list all active tasks, any tasks that are running here at the top, and here below we have a list of all previously completed tasks. So as I spoke about before, we have our spacecraft configuration section. I don't want to go too in depth here. If you have any questions, feel free to reach out or whatever. But here you can, edit ground stations, add ground stations, edit regions, add regions. We have our spacecraft configuration parameters with all those sections that I spoke about before. Yeah, so you basically all of these fields here are going directly into FreeFlyer objects and configuring various fields there, such as the propagator, force model information, etc. So let me go ahead and go to our products page. So I just received a 24-hour span of GPS telemetry data for Landsat in for January 1st. Excuse me. For January 31st, 2018. So I'm going to draft that in here. Click this import button, and it's going to do some conversions, both convert GPS time to UTC time, convert ECF coordinates to ECI coordinates, and then it's going to save it as a product in Meridian so that I can look at a QA. I see we have 26 hours worth of data here, have about 7,000 data points here. So I'm going to now use that product. I'm going to approve it to flag it so that I know to use it in the orbit determination daily orbit determination task. So I'm going to click the task drop down here. I'm going to go to the orbit determination task, select my spacecraft. I'm going to choose another Meridian product, the state vector, as input. So let me sort it so I can find the right one. I'm going to use this January 31st 1200 state vector, and I have some other configurable parameters here, such as duration, max allowable sigma, which will go to common filter. Each task is going to have this. You're going to have input products and then various other input values to go into the task. I'm going to click the GPS tab here to select the GPS telemetry file that's relevant. Sort it here, and then there's my approved check mark that I did when I imported the task. Or when I imported the file. So I'm going to select that. It brings it up to this selected box, and then if there's any maneuvers in the span, it'll show up here. But there is no maneuvers in the span. So then I'm going to go to this this run box in the top right here and run the task. And once I click run, it takes me to this task summary page, which is going to list all of our inputs and kick off all the log messages that are being sent back from the FreeFlyer task itself, so that I can QA it, do whatever I need to do. So to save time, I ran this earlier, so I'll go to the completed version of this and see. As you can see, it popped up into the active tasks section here of the page. But I ran the same exact task earlier, and so I want to show you the outputs, which we would use the outputs and QA the outputs. So we have this definitive state, which we would then use for both maneuver planning and ephemeris generation. So this is our definitive state, our definitive output state that the common filter solved for using our yesterday's definitive state vector and processing our GPS data. This was our state 24 hours after our input state. I'm going to, I can QA the ephemeris and export this definitive ephemeris. Definitive, I click the export arrow to bring up an export dialog. I'm going to export the definitive ephemeris to save in case we ever want to go back and analyze different things, analyze our historical orbit data. So I can export that in file format, download it right from the browser. And then another good way to, so yeah, it's going to save the file directly as I would any file that I download from the internet. I'm going to do some more QA. I can see that 99.5% of these points were rejected, or were accepted from the filter. So I can already be pretty confident that this is going to be a good solution. But I also have a slew here of plots that I can further QA, such as the filter state. So we see that it converged right away. And it looks like towards the end of this data set, maybe we didn't receive as much GPS data, like maybe the GPS stopped, or the GPS file only had data up until 600. So it started to diverge at the end, but can still be confident that our force model was set up properly to still give an accurate output state from the orbit determination. So I can show a couple other plots here. I want to see specific velocity residuals at each epoch. You can see not very noisy. So some good data here. So I'm going to go back into that output state vector and approve that. So I know to use that in my next tasks. Computer's going slow here. Okay, so I'm going to approve this state vector. And then I'll go to the next task in our product flow is maneuver planning. So I'm going to select that state vector that I approved, definitive approved state vector. And I'm going to run the task, make sure all my inputs are set. These are just parameters that are going into the targeter sequence. I'm going to run the task. And also to save time, I ran this task earlier. So let me go to the same exact task. You see, this was the approved state vector that I just used, that I just generated in OD. So this one saw that we were outside of our control box, or getting near the limit of our control box. So it looks like we definitely need a maneuver right around it solved for one around the February 5th time frame. So here's our drag makeup maneuver, which is just a simple SMA raise. It solved for this drag makeup maneuver. It looks like we need about a 0.5 second duration burn here to make up for this, to stay within our control box. And we can check the logs here to see that, sure, yeah, it needs a maneuver, or else it's going to violate ground track error limits, and then it logged out the each iteration of our targeter. So we see it converged at 0.5 seconds about. So now we have a drag makeup maneuver that we want to include in our orbit predictions. So I'm going to approve this drag makeup maneuver and go to the next task, which is our orbit propagation task, which is going to take whatever state we use and just propagate over our configured force model. So let me grab that same definitive approved state vector that we used in maneuver planning. I'm going to nominally generate a 7-day long, 60-second step-sized orbit propagation. I'm going to generate a TLE and I²RV, and I'm also going to propagate covariance. And then I'm going to click over to the maneuver tab. I'm going to select that approved maneuver. It's going to bring it up to the selected tab, and I'll now have the ability to inflate covariance over the maneuver if I want to. But I'm going to leave it as is for now. I'm going to run the task, and this is going to generate a predicted ephemeris for us, which is going to allow us to send out EFEMs to other subsystems, such as mission planning, to generate their planning products to build the spacecraft load, command load. And we're also going to send TLEs and I²RVs out to communication assets, and we're also going to send covariance EFEMs out to collision avoidance softwares, subsystems, and organizations. So I have this task finished as well. So you see they popped up an activation of the active task list. So I'm going to close out some of these deep blog messages so I can click into a completed run of the same inputs. So I'm going to make sure I export this ephemeris in all of the different formats that I need, or that other systems need. So I'm going to export a CCSDS EFEM and the FreeFlyer EFEM. I'll generate ITC EFEM with a burn in it, or I'll add this burn type to let the other systems know that there's a burn in this span. I'll generate an STK EFEM, and I'll go ahead and choose the my local file server, my local Windows file server as the destination. I'll click the export button, and I can export up to as many of those checkboxes as I want. I can export all the files at once, and so there they go. Successfully exported, so I can then send those files out to whatever subsystems or organizations need them. So let me go to the last task in the flow now. Well, first let me go ahead and approve this predicted EFEM, because this predicted EFEM is the main input for our orbit product generation task, which will generate orbit products for us. Created, approved. So this is going to create whatever these events that I select, such as view periods, calibration opportunities, eclipse periods, RFI periods, line of sights, node crossing, sensor interference events, region transit events, and the WR2 grid, which is specific to the Landsat, the sun synchronous orbit regime. So each of those events has additional inputs. I can choose the regions that you saw in configuration, the ground stations that you saw in configurations, and all this information is going to go into the task for each individual product type. So let me go ahead and run this task, and this one will take the longest. So let me go right to the orbit product generation, the run that I finished earlier. So you see I included a bunch of ground stations, regions, ephemerides, attitude ephemeris, and it calculated a half a dozen events that can go to our mission planning tools or whatever calibration validation software that needs to know this information, like any potential contact times with ground stations or data teachers spacecraft, good times for calibration, sensor calibrations, when we're in eclipse or out of eclipse, line of sights, node crossing, orbit numbers, beta angle at each node, no sensor interferences for this time span. We can look at any solar radio frequency interference events, and this is just going to show all the events that we selected on that main input page. So I can go ahead and export all of these files so that we can either use them internally for analysis, or we can send them out to whatever subsystem needs them. And just to show, just export all these files at once, no problem. And so, yeah, that's our, that would be the basic nominal product flow for Landsat. That's, going to be the main, one of the, the core of what we'll be doing when Landsat launches for both Landsat 8 and 9. And, we have automation capabilities to do this. We can utilize scripts to run to do these tasks whenever we want. We can schedule them to do it whenever we want. But I hope that this gave you guys a good overview of how Meridian is actually used. You might have seen presentations on it or heard about it, but you might not have been able to see what it would actually look like in an operational setting. So I'm hoping that this gave you a good overview, and I wanted to open up the last couple minutes here for questions with a little closing statements of why Meridian is a very useful tool for any mission that is looking to cut down on development time and even training time for your flight dynamics software.
Yeah, great job, Colin. Thanks for showing us all about Meridian. Our first question is from Steven, and he asks, how does Meridian create the attitude ephemeris? Does it have separate tasks for generating the attitudes to use in ephemeris propagation?
So, so Meridian doesn't do the attitude generation. We would export those that predicted ephemeris or definitive ephemeris or whatever, and then we would send that to our attitude determination and prediction software, and then we have a useful import for attitude ephemerides, that I didn't show here for time, but I just import the attitude ephemeris from which would be output from our attitude determination software that we have. We use a MATLAB tool to generate our attitude, and then we just, as far as Meridian concerns, we take that attitude ephemeris and import it and propagate our attitude right over the quaternions that are given to us from the state. Yep.
Awesome. Thanks. Can Meridian import telemetry files automatically as they become available, or do you have to manually import the file every time like you did with the click and drag just now?
Nope. Yeah, like I said, we have automation tools set up to we have a file watch component that will look for we'll just scan a specified directory, and every time it sees a new file, it tries to import it. And when the regex matches up that, oh, this is a GPS telemetry file type, it knows that it can export it, and then we have the scripts just kicks off a sequence of tasks, pretty much the same sequence that I showed, maybe with a couple more steps added in. But yeah, there's a file watch component, sees the new file, sends it to this Meridian import window. Basically does this call here for us and does the drag and drop for us. Does the request, doesn't drag and drop obviously, but imports the file automatically. Yep.
Awesome. Well, Colin, thank you so much today, and good luck to you and the rest of the Landsat team as you all prepare for launch later this fall.